Hello everyone, so here's a little video for getting started with this lab. So basically what we're building today is some keyboard serial port control of the color LED. So you can see in the video that we've got right now that we're able to change through and navigate through different colors, and so that's what we're going to be building today. Basically that is controlled through the serial port from our computer. So I just want to run through the basics of getting started over here in CodeWarrior. So I'm going to create a new project, making sure that the directory into which this project is created is the Git repository that you would have previously used. Select the type of board that we have, which is the MK20DX128 under 50 MHz. Select OpenSDA. This page is all fine. I'm going to be using Processor Expert here, so I'm going to turn that on and create that new project. So having a look in the components library, today you're going to be needing a PWM control, which you have been using before, so I'll just quickly go through some of the things. What you should have a look at here in this documentation is these examples of these generated signals to have a look at the difference between the initial polarity low and initial polarity high settings. So you can configure here ratio of 20%, ratio of 20% can have different meanings depending upon the initial polarity that you choose. So just think about that and think about how the LED is physically wired and in what sort of ratio, how you want it to be interpreted. So there's the PWM. I won't talk much more about that because you've used it before. The thing that's new about this lab is serial communications. So there's a few components that you can use for serial comms, which I'm just going to run through now. And the first one that I'll mention here is this asynchronous serial. So this is basically a low-level component that just implements serial communications. You can send single characters or you can send strings or a buffer of characters and also receive into a buffer. So I'll show you how that works. If I go ahead and add that to the project, we can have a look at the properties for it. So the first thing that we need to do for the asynchronous serial component is set the pins for the receiver and the transmitter. So these may or may not be the correct pins. So you have to go and check the data sheet, check the schematic, to figure out whether or not these are indeed the pins that you want to be transmitting on. You also have to supply a baud rate in here. So the baud rate is the speed at which transmission will take place. So we put in a number for that, and we notice that now there's no errors anymore on this component because we have specified that timing. Now this can work in interrupt mode or without interrupts. Basically, if you turn on interrupts, then it internally will allocate some buffers for input and output. So what this means is that if you want to have a transmit buffer with 128 characters, then you would type that in there, and similarly for the input buffer. And so to use this component, you would use one of these functions here. So for example, send block, you can see the prototype for it there. And if you have interrupts turned on, then this function will return immediately because it will simply enqueue the data to be sent, placing it into this output buffer, and then the component itself will take care of queuing up each individual character to be transmitted as the serial port becomes free. So that's asynchronous serial. That's how we would use that one. Let me show you some of the other components that we can use. So there's a component called console.io, which I'll show you. Console.io basically allows you to use functions like printf. So if you want to just do basic sort of C style input and output with the printf and the scanf functions, then this is how you would do that. So console.io actually creates this internal component, serial LDD, and again in here you have to configure the UART, so which UART internally you want to be connected to and which pins you want to be transmitting on and the baud rate. That's console.io. So in code you would use that simply with a call to printf. So I can open up main.c and I could write something like this. to send the string hello. I should put /r/n here. So this means carriage return, and then line feed will go back to the start of the line and then go down to the next line underneath this one in a terminal emulator. So that's how you would use console I/O. Now one more option that I want to point out to you is called term. Now term actually doesn't come up by default. You have to turn off this filter here. When you turn off filter, you see a whole lot more components, and here is the term. And so what this provides is basically input for a terminal emulator. So terminal is a very old style of computer display that was basically a grid of characters where you could put some particular text in a particular location, like an X and a Y coordinate, in a particular color. And so this component here provides a wrapper around that kind of system. So you see, for example, we have a set color function here, so we can set the color of the text that will be appearing in our terminal emulator. We can clear the screen with this CLS function, and there's move to that will give us the coordinates where we can move to, and then by sending a character or sending a string, it will write out into that location that we have previously moved to. Now the term component actually generates, or it contains internally, an asynchronous serial. So once again, asynchronous serial, you have to go through and configure the pins and the baud rate that you want it to use. And so you would drive this component by using these functions that you see down here. You probably want to turn on interrupts in this case so that our transmit functions can return immediately, and then let the internal components take care of making sure that all of these characters get transmitted. So that's how you would use it inside Processor Expert, but how would we connect to the device itself? Well, for that we need a terminal emulator, and so a program that you can use is this one called PuTTY, which is installed on the JCU machines. So if you go and click here on serial, and then you have to specify which serial port you want to use. So how do you figure out which serial port? You go into Control Panel, into Devices and Printers, or Start Menu, Devices and Printers, and you see that OpenSDA hardware will appear here. If you go right-click Properties, change to the Hardware tab, it shows you all of the components that are part of this USB device, and one of them is called CDC serial port, and you can see that on my computer it's been allocated COM5. So COM5 is the number that we want in this case. So I'll go back into PuTTY, select COM5, select the baud rate that I had previously programmed in CodeWarrior, and press open. And so now my terminal emulator is connected, and so if I had some code running on board, then I would be able to see the text coming up down here, but I haven't programmed the board yet, so at the moment nothing is going to happen there. So that's the basics of how you would get started. So you can use any of these components that I've talked about. When I did the solution, I used this term component because you can see in the prac sheet that I've been setting different colors for different parts of the display, and so that's how it was achieved. It was using this particular component here with these set color function here.